Alright, second attempt at this. There's been a few attempts at getting this right. It's the video for blazemaster, YouTuber that's been asking a few questions about Scorpion 2. It just so happens that I've got Scorpion 2 machine over there. So, wonder what you thought of my rig. Taking full advantage of the fact that flat panel TVs can connect to computers these days. Who needs a computer desk anyway? Anyways, you tell me you're measuring this diode here, D6, it's coming off of pin 13 in the power supply. This is your, what they call the 12V line. It's basically the 12 volts unsmooth line, which gives you a pulsing signal coming through here. You tell me you're measuring this diode and it's measuring both ways. Well, what I say to that is you need to take that out circuit first. To measure it, you need to take it off the board. If you measure it on a diode test in the board, you're going to get a false reading because it's highly likely you're going to be performing a diode test across that transistor instead. You're going to accidentally test the transistor instead of the diode, so take the diode out the board first. I don't think that's your problem anyway. I mean, it might be. I think your problem would be more likely to be battery damage at the RAM supply. So, what you need to find, as you can see, I do have a copy of the Scorpion 2 schematics. If I take you back to the processor itself, you see the RAM supplied by a line called VBAT. It's not the same as the 5 volt supply for the rest of the board. What you need to do is measure the voltage at pin 28 on IC4. It's a 6264 RAM. Very easy to find. It's just to the right of the program card. Can't really miss it. Measure the voltage at pin 28 there and pin 14 there. If it's lower than about 4 volts, you've got a problem with the RAM supply. RAM supply is derived, just go through this a little bit. Here. If there's any issues with your RAM supply, you're looking at this circuit here. You need to find D44 and R93 and measure the junction between them. You should be getting about 5 volts there with the board powered up. If you're not, as a quick fix, what you can do is tie the supply from there to there. You remove D45 and R93 first and unclip that switch. That switch basically to allow you to do a RAM clear without having to remove the battery or short the RAM out or do other various things that we have to do, and other daft things we have to do on other boards, like put a different program card in, whatever. This area here is right next door to where the battery would be. Sometimes when you look at the board, this switch is missing. It's sometimes got a wire link, it's sometimes been taken off and makes the battery ineffective. If you're starting up your machine and it's saying RAM clear error all the time, then that could well be the problem. Usually the battery will kill the junction here or here. Like I said, it's a temporary fix. You could tie the 5 volts from there to there. As for the name of the diodes in the reset circuit, if you want to, I'll leave this up for you for a minute as well. This gives you the technical description of the reset circuit. probably a little bit unwinded. I'll explain in a minute what they mean by this, because that can confuse some people, how you get 100 Hz from a DC power supply. But if you pause it on here, you can read this, and then we go to reset circuit. The diodes themselves in question, the ones you're talking about, are 1N4148s. The very run-of-the-mill standard stuff. There's one there. There's one at D7. There's another one somewhere at D3. These two here, they're more or less acting as flywheels. They're to stop voltage transients causing false resets, basically. Now, the way this works, if you read the technical description, understood it, fair enough. If you don't understand it, all the thing you need to remember is this is your reset, but it's triggered by this. When you first start the board up, this timer's output goes high, resets on, that charges up. Once that charges up through this, that goes low, resets off. Once resets off and the board's running, you got a pulsing signal coming through here, and you get the 12-volt unsmooth coming through there. It says in technical description roughly it's a 100 Hz signal. How, you ask, will you get 100 Hz from DC? Well, remember it said these 12-volt unsmoothed. When you've got grab a pen and a bit of paper here. Use everybody's emergency paper, but an envelope. When you've got an AC signal, if that's 0 volts, an AC signal is running about 50 Hz, like that. Each complete cycle is happening 50 times a second. Now, when you put it through a rectifier and the 12-volt unsmooth comes straight off the bridge rectifier, you're turning all the negative halves up like that. Every one of these is now up here. So that is roughly twice the frequency of that. See? One cycle, one cycle, one cycle. It's roughly twice as fast. And that is how you end up with a 100 Hz signal coming through there. Now, go down to the power supply circuit. The 12-volt unsmooth line comes in for the rectifier. I've actually got the power supply circuit here. I don't know if it's actually on the schematics. Maybe the only thing that's not on the schematics. There we are. It doesn't show the schematics for the power supply itself. But if this signal is missing, if you measure it across, if you measure it at that transistor and the signal's missing, check fuse F4 in the power supply. Because it feeds the unsmooth line. Like I said, I reckon your fault's going to be there. It's either going to be there or you're going to have either a bad trace with cutting out the power from the expansion ports where your ROM card plugs in, or cutting the power to the CPU. I would check your RAM supply first, but by all means replace D6 and that transistor and see if it makes any difference. Let me know how you got on. I'm sorry this video's a wee bit jittery, but very late at night and everyone's asleep, so I can't be too loud and I can't be opening up machines and stuff yet, but let me know how you got on.